All right, everyone, we are back, and we are about to solve our first problem on our exam 2. 3-point bending force at fracture. Running some bending tests, DLT boards, blah, blah, blah. Normally distributed, so our mu has a population mean of 150 newtons. Our population standard deviation is 10 newtons. We tested our number of samples is 1765 boards, and we found observed expected. So we observed 36 greater than 178. So we also found 36, 1, 3, 4, 5, between 130, 180. Let's scroll down a little bit here. 786 is going to be between 120, 145. Let's scroll down. 789 are going to be between 149 greater than, and then 1300 boards less than 175. All right, so is this basically, does the sample come from a normally distributed population with a significance of 1%? So let's go ahead and let's get set up here. So we have our Z function, we have our PDF. So now let's get our observed list. So our N is going to be equal to 1765. Our observed is going to be equal to, so we found again 36, 1, 3, 4, 5, 786, 789, and then 1300. And then our expected list is going to be, so we need to do so the first one is saying 36 boards greater than 178. So 178. Our mean is 150, and our standard deviation is 10. So we want everything greater than 178. So this to infinity times n, and this is going to be our expected 1 value. Our expected 2 value is going to be greater than that, between 130 and 180. So here we need to do 130, and then we need to copy this and just go from here to here. 180. And expected 2, expected 3 is going to be equal to expected 3, 120, 145, and we have a greater than, did we get 789? Yeah, so expected 4 is everything greater than 149. So we're going to 149 and then infinity. And then finally expected 5. And you're seeing a big difference, so I bet you we're going to have a big old reject. And then finally less than, so now we're going from minus infinity, and then less than 175. So observed, expected. So let's do expect 1, expect 2, expect 3, expect 4, expect 5. Here we go. Let's get our observed expected. This is our chi-squared experimental. That's a huge chi-squared. So we're going to have 1, normally distributed, 2, not, 3, alpha is equal to 0.01, 4, our chi-squared experimental is like 500 something, 5, our chi-squared 0.01, our nu is equal to 1, 2, 3, 4, 5, k is equal to 5, 5 minus 1 minus 2, so that leaves us with a nu of 2 because we're fitting our function. We look at our chi-squared table, 0.01, 2, so that leaves us with 9.2, 9.2, and then that will give us the following, so this is like 9.2, or like 5,000, so that is a big old reject. for sure. And that makes sense because they're very different. All right, we'll see you on the next problem. See you then.